Hello everyone, this is the video supplement for our submission, Continual Skill and Task Learning via Dialog. We want our robots to perform household tasks such as cooking with us. Unfortunately, the robot might not know all the skills to cook an arbitrary dish for the user. For example, a robot is making onion rings for the human user, and it does not know how to cut onions into rings. In this scenario, the robot needs to express its confusion to the end user in an interactive way such that the user can provide the appropriate help for the robot. For a novice end user, the interactions with the robot need to resemble natural interactions between humans, such that they can interact with the robot without any prior expertise. Natural interactions include dialogue, human performance, and robot trajectory guidance. Furthermore, the robot needs to learn task-relevant knowledge from the interaction with the user, so that when the robot encounters the same task again, it can finish the task on its own. To build such interactive agent, we need to answer the following question. When should the robot ask questions? More specifically, how does a robot know that it does not possess a skill to perform a task? We use a method that is inspired by active learning. Our agent maintains a language representation and skill representation for each skill it knows. The agent can also encode the linguistic description and the human performance of the novel skill into the linguistic embedding space and the skill embedding space respectively. Furthermore, the agent uses a LLM to ask the corresponding questions to the human users at different states. When encountering a new skill, the robot first searches for a usable skill by comparing the linguistic representation. If the agent finds a usable skill based on the linguistic embedding space, the agent uses that skill to perform the novel task. Otherwise, the agent asks for a human performance of the novel skill from the user, and then searches for a usable skill in the skill embedding space in a similar fashion. If the agent fails to find a usable skill in the skill embedding space, it understands that it does not possess the skill to execute the task, and will ask for teleportation-based demonstrations to learn this skill. We also introduced the novel Act LoRa policy for the agent. Act LoRa combines the low-rank task-specific adapter with the action chunking transformer. On top of Act, it introduces a specific set of low-rank weights for each skill on each MLP layer of the architecture. As a result, our policy inherits the ability to perform fine-grained control on the robot from the Act architecture, and can continually learn novel skills without forgetting the old ones. We conducted a human subject study to evaluate our agent. With the human subject study, we show that our agent can learn novel skills from interacting with non-expert human users. Furthermore, our policy achieves a 75% success rate of making the entire sandwich, which uses both the pre-trained skills and the newly learned skill. The agent with our Act LoRa policy is also significantly better than the same agent with the TEL continual learning policy in both objective metrics and subjective metrics. We will show a video that demonstrates our agent with the Act LoRa policy in the two phases of the study sequentially. We first demonstrate our agent in the interaction phase. At the beginning of this phase, The robot agent asks the human users for the sandwich that they are looking for and the instructions to make the sandwich.
Hello, what type of sandwich can I make for you today?
Hey, can I get a lettuce sandwich with cheddar cheese and butter?
Could you please describe the steps involved in making this lettuce sandwich with cheddar cheese and butter?
Yeah, of course. So first you put a piece of bread on the plate, and then you apply some butter on the bread. Then you add a piece of lettuce on top of the bread, and then you cut the cheddar cheese. After that, you add the cheddar cheese on the bread, and finally you cap the sandwich with another piece of bread.
Thank you for the detailed instructions. I'll start making the sandwich now. Let me know if you need anything else.
The robot in this video is pre-trained on multiple tasks, such as picking and placing the bread, applying butter, and adding lettuce, etc. We designed a brush and a blade for the robot to apply butter and cut cheese. We used pre-specified waypoints to pick and place these tools. The robot agent does not know how to cut cheddar cheese and will seek help from the user.
I have completed place bread on plate, apply butter, add lettuce. I need your help. I do not know how to cut cheddar cheese.
It first raises the user's attention and informs the user that it needs help.
However, I know how to add cheddar cheese on bread. Can I cut the cheddar cheese using the same movements as I add the cheddar cheese on bread?
Then, based on the linguistic representation, it proposes to use the movements of adding the cheddar cheese on the bread to cut it, which is clearly impossible.
No, you can't. They're different.
It seems I don't yet have the skill to cut cheddar cheese based on your description. Could you please show me how to do it in front of the camera?
After the user rejected the robot's proposal, the robot requested the user to perform the task in front of the camera so that it can search for a usable skill in the skill space.
Yes, of course, no problem.
As shown in this video, the human user agrees to perform the task for the robot and help the robot learn.
I do not know how to cut cheddar cheese. Can you please teach me how to do that by controlling my arm after I finish making the sandwich?
The robot realized that it does not possess the skill to cut the cheddar cheese after seeing the user's performance, and asked the user to perform teleoperation demonstrations for it to learn the skill later.
Yeah, no problem.
The robot moved on to the remaining tasks of making the sandwich after finishing its interaction with the user. By asking for help and collaborating with the human user, our agent successfully made the sandwich in the interaction phase. After the robot is done with all the tasks, the user provides the teleoperation demonstrations for the robot to learn the skill of cutting the cheddar cheese. We use the trajectories collected from the users to fine-tune a new low-rank task adapter on the Act LoRa policy. In our human subject study, the agent was able to learn to cut the cheddar cheese using only 3 demonstrations from the users. In the evaluation phase, the robot agent is making the exact same sandwich for the user as the one it made in the interaction phase. However, this time it does not need the instructions from the users, because it remembers all the steps to make the sandwich from the interaction phase. Furthermore, the agent is now equipped with all the necessary skills to make the sandwich, such that it can complete all the tasks on its own without any help from the user. Thank you very much for watching this video. For more detailed information, please go through the main paper. For a longer robot demonstration of the human subject study, please visit the associated anonymous webpage in the main paper. Thank you.